Hey everyone, Mr. Hauk here. In today's video, we're going to be using the law of sines to solve real-world application problems. So in the last few lessons, we've been studying the law of sines, when we're allowed to use the law of sines, and how we use it to solve oblique triangles. Oblique triangles, and really triangles in general, have a pretty large variety of applications in our everyday life. They end up being relevant for things like construction, navigation, and really any problem where we need to measure distance, but it can't be directly calculated. So you're going to see three different problems here. Some of them are your pretty standard law of sine problems, and you'll see one pretty cool problem at the end, which is falls into an ambiguous case scenario, and that's going to be a pretty special problem you'll see. So our first problem here is a problem about navigation. Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates the bearing of the ship from Zulu is north 40 degrees east, which just means 40 degrees east of north, and the call to Station X-Ray indicates that the bearing of the ship from X-Ray is north 30 degrees west, which just means 30 degrees west of north. And luckily we were given a picture here, or we would have had to come up with this picture ourselves. But let's take a look at this picture real quick. So here's the angles that we were given in the beginning. Right here, the 30 degrees and the 40 degrees. And notice that with these 90-degree angles, that tells us these angles right here are going to be 50 degrees, and this is going to be 60 degrees. And in this picture, we already had the sides labeled. We're told that this side is A and this side is B. So because of that, I went ahead and labeled Zulu as A. So 50 degrees is the measure of angle A. And I went ahead and labeled X-ray B. So 60 degrees is the measure of angle B. And notice that I'm labeling Zulu A and X-ray B because they're across from their indicated sides. So, across from 50 degrees is side A. So this should be angle A. Across from the 60 degrees is side B. So this should be angle B. And then we have angle gamma right here. This is the Greek letter gamma. And across from gamma is the 120-mile distance between the Coast Guard stations. So the question here is, how far is each station from the ship? So what we're looking for, what we're trying to find, is A and B. But before I can find either A or B, what I'm going to have to do is, does that make sense? Need to have to do? I don't know. Well, what we're going to need to do is we're going to need to find the measure of angle gamma. And we already know that angle A is 50. We know that angle B is 60. So finding the measure of angle gamma is very simple. It's just going to be 180 degrees minus 60 degrees minus 50 degrees, which gives us 70 degrees. So angle gamma, 70 degrees, very simple. Now that we know the measure of angle gamma, we can go ahead and start finding these missing sides. I decide to set it up the first one like this. So I want to go ahead and find the measure of side A. Well, if I want to find the measure of side A, I'm going to say the sine of angle A over side A equals the sine of angle gamma over side gamma. And that's what I have right here. Sine of 50 degrees over A equals the sine of 70 degrees over 120. And we can see, I'll zoom in on this. To solve this for side A, we go ahead and cross multiply. A times sine of 70 degrees equals 120 times the sine of 50 degrees. We know we're trying to solve for A, so we divide both sides by the sine of 70 degrees. And we get that side A is 120 times the sine of 50 degrees divided by the sine of 70 degrees, which if you plug that into a calculator, and if your calculator is correctly set to degrees, you'll find that A is approximately 97.8 miles. So that's the distance from the ship to Station X-Ray. That's this distance for A here. So next we want to find the distance from the ship to Station Zulu. So now again, we're going to use the law of sines. We're going to say, okay, well, we want to find side B here, so we'll do sine of 60 degrees divided by side B equals the sine of 70 degrees divided by 120. And then the same deal, we're going to go ahead and cross multiply. We get B times sine of 70 degrees equals 120 times the sine of 60 degrees, And then we know we'll divide both sides by the sine of 70 degrees, and we get that B is approximately 110.6 miles. And again, B is the distance from station Zulu to the ship. And we're done. We achieved the goal. We found how far each station is from the ship, and we can move on. All right, in our next example, we're going to be looking at the highest bridge in the world. According to the Guinness Book of World Records, the highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at water level directly under the bridge are taken from each side of the 880-foot long bridge. We want to know how high up is the bridge from the water level. And once again, we were given an image here. Notice that from each side of the bridge is 880 feet. This is where the sightings are. So one sighting is from this side of the bridge. The other sighting is from this side of the bridge. They're looking at the same point down here, and we'll call that point A. I'm just calling this B, and I'm calling this C. I'm just giving these labels, so it's a little easier for me to set up equations here. One thing to notice, though, is that this point in the middle, they're saying it's a point directly under the bridge. At no point in the problem did they say that this point was directly in the middle of the bridge. So this is not the midway point, okay? Very important to understand. It's just a point under the bridge at water level. And the problem also gave us the angles. So the angle from this sighting to this point relative to the bridge is 65.5 degrees, and this angle over here is 69.2 degrees. So what we're trying to find is how high up is the bridge from water level. We're trying to find this H right here. Well, notice since this point, this common sighting point underneath the bridge is directly under the bridge, this is going to create two 90-degree angles, which means we're going to get two 90-degree triangles. This one highlighted in green, which is the one I end up using, and this triangle that I haven't highlighted, but is still a 90-degree triangle, okay? So let's think about how we're going to actually solve this. If we want to use the law of sines, and we're allowed to, by the way, because we have an angle, and an included side, so we can use the law of sines to solve for the missing pieces. But if we use the law of sines, we're going to be solving for B and C and angle A, but we won't be solving for H, the height. Law of sines isn't going to find that for us. But one thing that we can do is if we can go ahead and find side B, then we can use the 90-degree angle, the 65.5 degree angle, and this side, and use the law of sines on this triangle right here, or we could just use, alternatively, we could just use, since it's a 90-degree triangle, we could use something like SOHCAHTOA to solve it, okay? But my goal here is I'm going to go ahead and try to find side B, and that, along with the information of this 90-degree triangle, is going to help me find the height here. So in order, though, to find side B, I'm going to need to know what angle A is. So that's the first thing that I do. I go ahead and solve for the measure of angle A. It's going to be 180 degrees minus the measures of these two angles, and that's going to give me 45.3 degrees. Once I've done that, I'm going to work on trying to find side B. So the ratio that I set up, or the equation that I set up, is sine of angle A over A equals sine of angle B over B. We know that angle A is this 45.3 degrees we just found, and we know that side A is this 880 feet, because that's what's across from angle A here. Sine of angle B over B, well, we know that angle B is 69.2 degrees, so sine of 69.2 degrees, and B is what I'm trying to find here. It's going to help me in the second part of the second half of the problem. Okay, so once we get to this point, it's just a pretty standard problem from here. We'll go ahead and cross multiply. We get B times the sine of 45.3 degrees equals 880 times the sine of 69.2 degrees. Then we'll divide both sides by the sine of 45.3 degrees, and we get that B is approximately 1,157.4 feet. I'm just rounding at the first decimal place. That's what I'm getting there, okay? So now, here's the idea. We just calculated that side B right here is 1,157.4 feet. We also know that this is 65.5 degrees and that this is a right triangle. So I'm going to use properties of right triangles. I'm going to use the trigonometry of right triangles that we learned in the first part of this course. So using the right triangle that I have highlighted in green, I can say that the sine of the angle, well, we know that in a right triangle, sine is the opposite side divided by the hypotenuse. Well, the side opposite of 65.5 degrees for this green triangle is h, and then the hypotenuse is b itself, because that's what's across from the 90-degree angle. So the sine of 65.5 degrees is h divided by b, but we know that b is 1,157.4 feet, so the sine of 65.5 degrees equals h over 1,157.4, and we can multiply both sides by that number on the bottom, and we get that h is approximately 1,053.2 feet. And that's the height that we were looking for, the height from the water level up to the bridge. And the next problem is my personal favorite. This is for all of y'all that were watching the Super Bowl on Sunday. I made this problem right after the Super Bowl. So this problem is about the GOAT, the greatest of all time, Tom Brady. In this problem, the year is 2055. Tom Brady is playing in his 40th Super Bowl. His goal is to win a Super Bowl ring with every team in the NFL. Brady, being the cyborg that he is, has calculated the spots where he knows two of his wide receivers are going to turn around to catch the ball. Wide receiver A is 22 yards away from Brady, wide receiver A being right here, and wide receiver B is 18 yards away. Wide receiver B is right there. If wide receiver B has an angle of 92 degrees between his lines of sight to wide receiver A and Brady, then how far apart are wide receivers A and wide receiver B? So let's take a look at this picture here. Down here, this is obviously Brady, the GOAT, greatest of all time. And I'm going to go ahead and call this point G for GOAT, meaning that the side across from angle G is going to be side G. Here we have angle A, and here we have angle B, meaning that the 22 yards, the side across from angle B, is going to be side B, and across from angle A is going to be side A, the 18 yards. So we're trying to figure out this distance between the two wide receivers. We're trying to figure out the distance, little g. So in order to do that, we're going to have to use the law of sines. But notice that this is actually an ambiguous case problem. We were given a side, and this non-included angle. This 92 degrees, that's this angle right here. So because we have an ambiguous case problem, first we need to figure out how many solutions this triangle is going to have. Well, notice using that little visual trick that we talked about, if we go from 92 degrees, trace around to the side opposite of 92 degrees while going through the other side, we can see the side that we go through is smaller than the side across from the angle, which means that we're going to have one possible triangle. So we can just solve this triangle as if it was a normal problem. Looking at the information given to us, we have angle B, we have side B, and we have side A, which means the only piece that we can find, at first at least, is going to be angle A. So that's what we do first here. We set up the equation sine of angle A over A equals sine of angle B over B, plug in the pieces right here, cross multiply. We get 22 times the sine of angle A equals 18 times the sine of 92 degrees. And then, of course, we will divide both sides by 22. And since we're trying to get angle A, we're going to have to get rid of this sign right here by taking the inverse sign on both sides. Plug that into a calculator, and you get that angle A is about 54.9 degrees. So thinking about the next logical step, well, now that we know angle A is 54.9 degrees, and we already knew angle B was 92 degrees, that means we're going to find angle G. So angle G is 180 degrees minus the two angles that we have now. That tells us that the measure of angle G is going to be about 33.1 degrees. And now that we know the measure of angle G, now we can finally find the piece that we're looking for, which is side G, the distance between the two wide receivers. I set up the ratio as sine of angle B over B equals sine of angle G over G. The reason I'm using side B and angle B It's because it's the information that we were given originally, and that information hasn't been rounded. It makes the problem a little more accurate for you. So using that information in combination with angle G that we just found to be 33.1 degrees, this is the equation we get set up. Again, we're going to cross multiply. We get G times the sine of 92 degrees equals 22 times the sine of 33.1 degrees, and that's going to be about 12 yards. So the distance between wide receiver A and wide receiver B is about 12 yards.